In this video, we will look at two rules for dividing radicals. Notice the note at the top says the quotient of two square roots is equal to the square root of the quotient. Now the quotient just means the answer we get when we divide the two numbers together. Here, this is just a restriction outlining that for square roots, we need positive numbers. So let's just take a look at using this rule. I've got the numbers 12 and 6. I know those numbers can be divided, so I'm just going to rewrite this as the square root of 12 divided by 6, and this just gives me the square root of 2, which is my answer. Now let's look at another note. In this question, note that it says that we're working with mixed radicals. So when it comes to mixed radicals, it says I need to also look at the quotient, or in other words, divide the coefficients which are at the front. So right here, these are indicated by the letters C and D. They would get divided as well. Now, if you notice right here, you might say, well, those aren't mixed radicals. But if we take a second and rewrite them as mixed radicals, then we can have a look at the question. So over here off to the side, I'm going to use the method of extracting the largest perfect square. So I know 4 times 5 gives me 20, and the mixed radical which results from this would be 2 root 5. The same idea over here with 45. I know the largest perfect square which multiplies to give 45 is 9 times 5, so that would give me 3 root 5. Now this results in two mixed radicals. Root 20 is 2 root 5, and on the bottom I get a 3 root 5. Now if you notice, 2 and 3, they can't really be divided by one another, so I'm going to keep that as a fraction 2 over 3. When I look here, the square root of 5 and the square root of 5, though, can be divided to just give me the square root of 1. So I'm actually going to think of it as giving me a 1 or canceling those terms, so my answer that I'm left with would be 2 over 3.